In the second set of examples, we're going to look at converting from rectangular notation back to polar notation. Once again, it is best to draw this out so that you can clearly see exactly what you're doing, and then we'll use the trigonometry equations to solve for our answers. In this case, we have negative 60, so we're going to be going to the left, 60, 40 down. Now, whenever you draw vectors, the two components of the vector are drawn head to tail. So I would always draw my starting point as a dot, draw the first vector. Where the first vector ends, draw the second vector. The vector I'm looking for is the one that connects from the original dot to where I ended. So to find the length of this, I'm going to use the Pythagorean theorem. A squared plus b squared equals c squared. So 60 squared plus 40 squared equals c squared. 5200 equals c squared. Take the square root of that. I get 72.11. So it's going to be 72.11 meters long. I also need an angle to be in polar notation, so I'm going to first solve for this angle on the interior here. To do that, I'm going to use the tangent equation. Tangent of an angle equals the opposite over the adjacent. So the tangent of this angle equals 40 over 60. To solve for the angle, you'll remember from our first chapter, do the inverse tangent of 40 over 60. Get 33.69 degrees. Now, my answer is just not 72.11 at 33.69 degrees because we always have to go from the positive x-axis. So we got to go all the way around. So in this case, I'm going to have to add the 33.69 to 180 to get the angle. This is why it's so important to draw everything out. So I'm actually at 213 degrees. My answer should be somewhere between 180 and 270. So I did 180 plus 33 to get this total angle. So my final answer, 72.11 meters at 213 degrees. The second one here, 25 meters at negative and negative 45 meters. So we're going to draw this out again. This time, I'm going 25 to the right because it's positive. Where the first vector ends, I draw my second vector, 45 down. And I'm looking for from where I started to where I finished. Once again, a squared plus b squared equals c squared. 25 squared plus 45 squared equals c squared. So 2650 equals c squared. So I get 51.48. The unit is meters. Now I'm going to find the angle in here. So tangent of the angle equals the opposite over the adjacent. So the tangent of my angle equals 45 over 25. So my angle is the inverse tangent of 45 over 25. Comes out to 61 degrees. 60.94, but I'll round it to 61. Now, once again, we have to look at where this angle actually falls. For polar notation, we go counterclockwise from the x-axis. So we need everything other than this angle. So to find our angle for the polar notation, we're going to do 360 minus 61, which will be 299 degrees. So our answer, 51.48 meters at 299 degrees. That should fit with the fact that since we're in this fourth quadrant, it should be between 270 and 360. So if this angle is 61, the total counterclockwise from the x-axis angle would be 299. It is very important that you draw these out so that you can see where the correct angle needs to be listed.